Hello students, welcome to Educate. Now in the 11th class, we will first chapter is some basic concepts of chemistry. Guys, as this chapter name is some basic concepts of chemistry, so you may predict by yourself that without the concept of this chapter, the understanding about the chemistry will be too much difficult. But here in the NCRT book, there is a number of portions uh, which has been written there, which can be understood by yourself very easily. So let's see here which will require here and which will utilize here again and again in the chemistry. Let's discuss. That is from the here development of chemistry here. What is that? That is the study part. That's you read by yourself. You will understand very easily. Same here. This one you can use very easily. Charak Samhita, what is that? This one you can understand very easily here. Okay, so now let's see here nature of matter from their importance of chemistry. What's the importance of chemistry? You also study there. What is here? Chemistry importance. That is the study part also. So you can understand by yourself. Here, now let's see. Because our whole life depends on the chemistry. So if we will understand the chemistry, then only the lifestyle of the human being will be comfortable. So that is the importance of chemistry. Like that medicine which you eat, that is based on the chemistry. That manufacturing, if there will be no knowledge of the chemistry, then manufacture of that drugs is impossible. In the same way, our human body, that is here, chemistry there is. So chemistry here, by the chemistry, the whole universe is depends. So here, when you will study the chemistry, then your lifestyle will become comfortable, and depending on that means sustainable also. Next one here, nature of matter. Nature of matter, that is matter is what? Anything which occupy this position, space, that is called matter. Anything which occupy space, that is matter here. These are pretty concepts here, and then after here, states of matter. States of matter, about that, let's start, and that is also you have already studied about the states of matter. You have studied in the 9th or 10th class. So that is here. What is so that is till now there is three states of matter. There is three states of matter: solid, liquid, and gas. What is about the solid? So solid here, in case of solid, that's definite shape, and definite volume. So in solid substance, the volume and the mass, that will remain constant. Mass and volume, that will remain constant. So definite volume. That means here definite shape, better here you write not on the place of shape. That means fixed mass and fixed volume, or definite, yes, definite shape and definite volume. Okay, solid substance, definite shape and definite volume. And what is that here? The distance between the constituent particles. There, in the case of solid, the distance between the constituent particles are very less. The distance between the constituent particles will be very less, and the constituent particles will be bonded with each other through a strong force of attraction. So in case of solid, the distance between the constituent particles are minimum among these three, that means solid, liquid and gas. The distance between the constituent particles, are minimum, and the force of attraction operating between the particles will be strong. So one is that. In case of liquid, so one point is that. Second point is that is about the solid. Solid substance when you keep anywhere, then their shape don't change. Obviously, volume also don't change. About that, you are already aware and in your day-to-day life. Then after about the liquid. About the liquid, volume will be constant, but shape will be variable. Like water, when you keep in the glass, the shape will be like that of a glass. When you will keep that water in a jug, then shape will be like that jug. So same here in any other substances, in any container when you will keep. So if the glass will be of a square shape, so square shape will be like a square, or like cuboid shape. So shape will be become cuboid. And if that will be a spherical, so shape will, of the liquid water become that of spherical. So here in the liquid, the shape is not constant, but volume is constant. And when a substance will act as a liquid, so in the liquid, the distance between the particles, constituent particles, in case of liquid, the distance between the constituent particles are intermediate. That is neither large, neither small. And the force of attraction operating between the constituent particles are also of intermediate magnitude. That is force of attraction not so much strong, not so much weak. If force of attraction will be strong, then distance between the constituent particle will be obviously less. Okay, so let's see. In case of gas, what happened? Gas volume will be not constant. So if you will keep a gas in a chamber, then the gas particles will spread in whole of the chamber. And if the same gas, there be in the same gas will be kept in a small volume, that means balloon, then shape of that gas will be like that of balloon, and their volume will be also in the balloon. Like in a balloon here, there is a gas, might we have studied, in a balloon there be gas, and when you will open that gas, then the gaseous particles present in the balloon, that will spread. If suppose you have opened the balloon in a room, so then the gas particles will spread in whole of the room. So here also, here in this case, the volume of the gas is not constant. Shape is also not constant, because initially balloon which was of a spherical shape, that when opened in the cuboidal room, then shape become cuboid. When a gas, that means how a particles will behave like a gas, then force of attraction operating between the constituent particles will be too much weak, and the intermolecular force of attraction between the gaseous particles will be too much weak, and the distance between the constituent particles will be very large. Okay, so in liquid, Okay, guys, how's the shape of about the gas? That was about it. This one pity concept here in the examination question also don't ask. What about the solid, what is liquid, and what is gas? That will not ask. That will also not ask what's the force of attraction opportunity between the particles and like that. Very easy questions. Now here about the gas, but it is in your syllabus, so that's why I'm discussing now about the gas also. Okay, guys, here I think you are already aware, and this concept we clear, that is the in solid, liquid, and gas. How's the shape of the liquid is not fixed, clear, because when you will draw the water in a container, then the shape of that liquid will become that of the container, but their volume will be constant. Like in a glass, if you keep the milk, and then after, so volume is like the volume of the glass. When you will keep that milk in the jug, so whole of the volume of the jug will not occupied by the milk or that of the liquid, any like oil or water, whatever you would like to take. And here but in the case of gases, the gas shape of the gas will be similar, same as that of the container. And when the gas will get open, that means when you will open the container, then the gases will spread. Okay, so that is shape, definite volume. What is that? Is, I think it's clear. Now let's see, proceed here. Solids, okay, what is here? When you supply the heat energy, then solid will change into liquid, and liquid will again change into solid. When the heat energy will supply to the solid, then suppose solid particles here, how that is here, like this solid particles. So when you will supply heat energy them between them, so what will happen? Heat energy supply. Guys, what heat energy do? That's increases the vibration. Heat energy is a form of energy. So that's when heat energy is applied to the particles, then the vibration of the particles will increase. So what happened here? Or you may tell amplitude of the vibration of the particles will increase. Like that, suppose initially particles was vibrating like this. When you will supply the heat energy, then particles will start vibrating like this. Again, then like this. Okay, so what is happened here? When heat energy will supply to the particle, then distance between the particle will increase. Distance between the particle will increase, and hence when the distance will be more, then force of attraction operating between the particles will decrease. Okay, when heat energy will be supplied to the solid, then the vibration, that means distance between the constituent particles will increase. Distance between the constituent particles will increase, and force of attraction operating between the particles, that will decrease. That's why solid will convert into liquid. Okay, same when you will supply the heat energy, then this liquid will convert into gas. Like this, distance will increase. So when heat energy will supply to a solid substance, then solid will convert into liquid, and when heat energy will supply to the liquid, then liquid will convert into gas. And in the same way, if heat energy will cooling means heat energy contained in the gas that you are taking out. Cooling means what? Heat energy contained in that substance that you are taking out, then cooling will take place. What is temperature here? When you supply the heat energy, temperature rise. When you supply the heat energy to a substance, then the temperature of that substance will rise, and when you will take out the heat energy from that substance, then temperature will fall. So that is here. When from the gas, when you will take heat energy, then obviously you are taking the heat energy, so particles will come closer to each other, and hence the solid gas will convert into liquid. Again, when you will take the heat energy from the liquid, then distance between the constituent particles will decrease, and force of attraction, when distance between the particle will decrease, then force of attraction operating between the particle, that will increase. So here, when you will take out heat energy, then gas will convert into liquid, and again liquid will convert into solid. These are the concepts from which questions usually don't ask in the examination. Usually, but that means don't ask in the examination. Okay, because these concepts are so much basic. Now, classification of matter, this one is important. Okay, from here the chemistry and starts. What is every substance? Here every substance is divided into two parts. One is called pure substance and another one is impure substance. Every substance is classified into two parts, that is pure substance and impure substance. Guys, don't consider that pure substance means beneficial for the human being and impure substance means harmful for the human being. That's not meaning. That doesn't matter here. Pure substance means that will be made up of only that particle. Pure substance means, suppose if there is water, if you will tell pure water, then in the water there will be no any other particle present in them. The water of tap water or any water which you are considering beneficial, like water of RO. So in that case, RO, there is minerals also. That's why someone tell that mineral water. So in that water, there is mineral also. So that is impure substance. Maybe some will disagree there, and in the day-to-day life, when you will tell that this water, that means mineral water, which you will purchase from the market, even though their cost 100 rupees of name of the company I forgot. That means their cost usually of their in the market there be some waters available which cost is less, like usually 20 rupees per liter, and there are some quality of water also in which the cost is at around 100 rupees per liter. So in but difference is that of the calculation of the minerals in both of the water, both type of water, there will be minerals. So that's also not pure water. Okay, there be minerals present. So if there be only water particle like distilled water there, so in distilled water there will be particles of only water and not any other substance. Then that will be called pure water. So pure substance. And impure substance like that, your mineral water beneficial for you, but when you ask that it's pure substance or impure substance, then that is impure substance. So every substance is classified into two parts, that is pure substance and the impure substance. Let's see here. About that, we will also discuss one by one. Substance, every substance is here. That is of two types, that is pure and impure. So it is pure substance and impure substance. Substance is of two types, pure substance and impure substance. Pure substance, that means that will be made up of only that particles, like pure water. If you will tell, if the question will ask pure oxygen, means in that container there will be no any other particle except the oxygen molecule. So that will be pure substance. Now this pure substance is classified into two parts, that is element and the compound. Okay, what is element? When you will divide, then only one type of particles will obtain, like oxygen there. So when you will divide the oxygen, then you will get the particles of only oxygen, like O2. In O2 here, when you will divide the oxygen here, this O2, so you will get oxygen atom and the oxygen atom. So oxygen is an element. Same as hydrogen. So when you will divide hydrogen, then you will get hydrogen and the hydrogen, atoms of hydrogen and the atoms of hydrogen. In the same way, when you will divide the sulfur, S8 like, so you will get 8 atoms of sulfur. So that is element. Same as in case of phosphorus. So phosphorus, when you will divide the phosphorus molecule, then when you will divide the phosphorus molecule, then you will take 4 moles of phosphorus atom. So that is phosphorus is an element. So that is element. And compound. Compound is actually made up of two different elements. Compound is made up of two different elements. Like water. Water formula is here H2O. H2O. So here H2O is water is made up of the atoms of hydrogen and the atoms of oxygen. The water is made up of the atoms of hydrogen and the atoms of oxygen. So that's why H2O, water, it is a compound. And hydrogen or oxygen, that is element. That is the example of element. So here example also I am writing. Example here like O2, H2, P4 and so on. Okay, and compound example here is like H2O, SO2, CO2. That is compound. That was element and the compound. Now impure substance here, in Difference in the element and the that means the compound and the impure substance is that here. Okay, that will get clear later on also. So in case of impure substance, that will be not made up of different particles. That means the substance that here element what will be here, compound what will be here, the ratio of the constituent elements will be always constant. Like water, when here when you consider about the water, so water here, so that is made up of hydrogen and oxygen. Let's see the ratio of hydrogen and oxygen. Hydrogen atomic weight 1 and there is 2 hydrogen, so that will be 2, and oxygen atomic weight is 16, so that is 1:8. So from any source of water, when you will separate the molecules of water, then you will find out the ratio of their masses will be 1:8. So here the ratio is constant. So that's why this substance is called compound. Okay. Same here as in sulfur SO2. So in SO2, the atomic weight of sulfur is 32, and here oxygen also 1 oxygen 16, and here is 2 oxygen. So that will be also 32. So that will be 1:1. So in SO2, the ratio of sulfur and oxygen is 1:1. That's why SO2 is a compound. Now same in case of CO2. In case of CO2, what ratio of their carbon and oxygen? Atomic weight of carbon 12, and that of oxygen is 16. 16 into 2, 32. That is 3:8. So in case of CO2, the ratio of carbon and oxygen is 3:8. So this ratio is always constant. From any source you find out the CO2 and separate the CO2 molecule into their constituent particles, then what happens? Their ratio will be always constant. So it is a compound. Now guys, just consider about the mixture which you have taken from the market. So what happened? From company to company, you may find out that there be in the mixture, there be peanut, groundnut, and maybe rice flakes. So the ratio of rice flakes, peanuts, groundnuts, the gram, and whatever with that any other substances, that is not constant. That is variable. In the same way, like there be when to tell another example, same way like in the pizza which you have eaten. So at the pizza, the ratio of tomato, capsicum, mushroom, sweet corn, that is not constant. That depends on your wishes. How much you would like more capsicum or the more tomatoes or the more cheese. So their ratio is not constant. So that will be called impure substance. Impure substance is the substance in which the ratio of their constituent particles are not constant. The pure substance is the substance here that is made up of only one particle. And when you consider about the pure substance, like here water, so water there. So when you will separate the water particles, then you will get particles only. So that will be called pure. That will be called compound. In this water, so in this water, the ratio of hydrogen and oxygen, that is here. So in case of water particles, that is there will be the element of only carbon and hydrogen. So that's why water is a pure substance, and it is a compound because water is made up of two different elements, two or more than two different elements. If the substance will be made up of two or more than two elements in a definite ratio, then that substance will be called compound. Okay, in the examination question will not ask what is element, what is compound. And mixture here, Impure substance, that is the ratio of their constituent particles are not constant. Same when you would like to eat ruh afza, ruh afza. So in that ruh afza, the ratio of the syrup which you add there, the syrup of ruh afza, and that of the water, the sugar, that is not constant. So what will be the ratio of the syrup, the water and the sugar? That will depend on your visage. So that will be the impure substance. Okay. So ruh afza is not harmful for you, but not harmful for you in the significant way. If you will critically analyze, then every substance has some harmful effect and some beneficial effect on the human being. So we consume that if beneficial effect is more than that of the harmful effect, then we consume. So okay, so ruh afza, that is beneficial for you, but that actually is a impure substance. Okay, so same here. If there be the mixture of sand and salt there, so the ratio of sand and the salt will be not constant there. So that will be an example of impure substance. So now impure substance, it is also of two types. Impure substance is also of two types. One is the when the composition remains same throughout, then that will be called solution, or that is called homogeneous mixture. Mixture, okay. Impure substance, it is also called mixture. Okay, mixture which you, this one impure substance, that is also called mixture, and this mixture is of two types. One is homogeneous, and second one is called heterogeneous. Homogeneous substance and heterogeneous substance. The homogeneous substance, that is also called solution. The homogeneous substance also called solution, or the homogeneous substance also called solution. What is that here? Homogeneous substance or the solution, the substance whose composition remains same throughout, that will be called homogeneous substance. And heterogeneous substance, the substance whose composition will not constant, that will be called heterogeneous substance. Let's see here. Like there is a sarbat here. In this sarbat, you have dissolved the sugar and the water. Here, there is water, and you have dissolved sugar. So now you do the experiment by yourself. The taste of the upper portion will be same as that of the lower portion. In the sarbat, the sweetness at the upper portion will be same as that of the lower portion. So that why that is happened? Because the composition here at the upper portion, the composition of the sugar and water is same as that of bottom position. The here the composition of sugar and water and the composition of sugar and water here will be same. So that is solution. But the mixture which you take from the market, which you purchase, so is there, like here is a mixture. So there is a mixture. So maybe here peanut, here groundnut, here rice flakes, here any other substance like pulses, fried pulse. So like that here is. So in this case, what happened? The taste of this portion will be not same as that of this portion. Okay, there you have kept the mixture here, and when you taken this portion, then you will realize that taste of this portion is not so much. Okay, so that is here. This substance will be called. This will be called here mixture. Okay, here composition do not remain same throughout. So that is solution, and that is heterogeneous mixture. Okay, that was classification of this substance. Now let's see. It has been explained here, like atoms of different element, different color, like this one. same hydrogen, different oxygen. So these are here. This hydrogen, it is element. So like hydrogen element, oxygen element, nitrogen oxygen element. When H2 you have separated. When one hydrogen atom and another hydrogen atom combine, and that is formation of compound. Hydrogen is an element, and when the two hydrogen atom has been okay. So this one here, hydrogen is an element. Same, oxygen is element. Okay, when hydrogen and oxygen combine, then there is formation of compound. Okay, water. And when in the water is a compound. Same, sugar is also a compound. So when you will mix the sugar in water, that will be the mixture. Okay, so that is, so element here, element combined together, then there will be formation of compound. Now to the two compound, when you will mix, then there will be formation of mixture. Okay, then after this here is properties of matter and their measurement. The measurement will be, that is, the parameter will be temperature, pressure, and so on. Okay, and that is here. Physical property, there is two properties here. Physical properties means about that we will, in the physical properties, which will consider about the, in physical properties, which we discuss about their melting point, boiling point, and when we mix the two substances, then what will happen. That is, so physical change, you know, which can be reversed, and chemical change which will not reverse easily. Physical properties means the properties which can be reversed easily. Like that in sugar, in water, when you will add the sugar, then okay, the sugar will uniformly mix there. But when you crystallize them, evaporate them, when you will evaporate the water, then again at the bottom you will get the sugar. So that solubilization is a reversible process. Same, when you freeze the water, there will be formation of ice, and again when you will supply the heat energy to the ice, so there will be formation of again water. So in this case here, the process are reversible. The process which can be reversed, that will be called physical properties or physical change, and the properties which cannot be reversed, like when you will electrolyzed, when you will pass the electricity to the water, that is here. So in that case, the water will dissociate into hydrogen and oxygen. So again, when hydrogen or oxygen you will mix, simply mix, and will not supply so much heat energy like that, then what will happen? The formation of water will not take place. Water is made up of hydrogen and oxygen, but hydrogen and oxygen, when combined at a definite condition, then only there will be formation of water. It not means that by simple mixing them you can form the water. So that is here, physical change means the changes which can be done by simple method. So physical properties, the properties which can be reversed easily, and the chemical properties means that will not reverse easily. That is called here physical properties and chemical properties. That is, so physical properties, this one, observed without changing the identity of the composition of substance, and the chemical properties require chemical changes to occur. Okay, that is, now let's see. Guys, these are where the petty concepts about which you are already aware, and here no frequently asked question here there be. In the examination, the question will not ask what is pure substance, what is impure substance, what is physical change, what is chemical change. About that question will not ask. But this one is the concepts which you should know. Okay, and I hope all of you are already aware by this concept. Now let's see measurement of physical properties. So physical properties, how to measure. So there is how to measure like that. This length is greater, just here. This length is greater or this length is greater. About that, to this one you will have to take a standard, and then this comparison measurement means always comparison. Like when you have purchased from the market something, and when you go through the market and ask the shopkeeper to give 1 kg apple. So what he do? He keep on a pan this one balance, this one on one plate he keep the standard weight, this one here he keep on one plate he keep a standard weight. That is, if you will go there and will tell that give me the 1 kg apple, then he will measure by taking this weight. When you will take to give 1 kg orange, then also he will take this one. When anyone will tell give 1 kg onion, then will take this one. To give 1 kg rice, then this one. 1 kg flour, then this one. 1 kg milk, then also this one. 1 kg banana, this one. 1 kg turnip, this one. So this weight standard, and everyone is agreed that if anyone will tell that the cost of apple is 120 rupees per kg, means when the weight of apple will be equal to the weight of this one, then he will have to pay 120 rupees. So this standard is fixed. So on the other pan, he keep the onion or like that. When this stick big vertical, then he gives you. So when this stick will be vertical, then this weight will become equal to this weight. When this stick will be like this, then it will come downward, and he will consider that weight of this substance is greater than that of this substance. So he take out, and he take out till this stick will not become vertical. When this stick will become vertical, then you as well as the shopkeeper and everyone will agree that weight of this one is equal to the weight of this one. So measurement means comparison, and to compare a standard required, and that standard is called unit. Guys, in the same way, when you will go to the market and tell the shopkeeper that I want 1 meter clothes, so what he will do? He will take a length scale whose length everyone considers as 1 meter. He will keep at the end of the clothes, and where at the end of the other end of the scale he states he cut the clothes and give you, and you realize that since this length is 1 meter and this width is equal to this length, so length of this cloth is also 1 meter. That is unit. Okay. Now a standard unit here. So there is a length mass time about this one. We discuss the international system of units in the next class. Okay. What's the international system of units? That's it. We will discuss in the next class. It's all for this class. And from these questions, frankly, I am telling you that usually question don't ask. Till now, what we have discussed, from there, the question don't ask directly. But if you will not have the idea of those concepts, then you will not understand the chemistry. Okay, guys. So listen this one also, but don't try to mug up. Okay. So it's all for this class. Thank you, Team Educate.